Now, what this allows us to do is introduce something called the chain rule for integration. So when the upper limit of an accumulation function is a function of x, rather than just the value of x, we make a U substitution and then use the chain rule. Okay, so here, if our antiderivative as a function of x, or the definite integral as a function of x, equals the definite integral from a to g of x, a function of x, of some function f of t dt, where g of x doesn't equal x, what we can do is we can let u equal g of x. Okay, and then if we were to take the derivative, we would say df over du of du over dx equals the derivative with respect to u of our f of x times du dx. In other words, we replace our function g of x with u right here, and we get this function right here. And we talked about how this will cancel out, and we're just going to be left with f of u. But we also have a du dx, which doesn't just become 1 in this case, because dx over dx is 1, but du over dx is not 1. So this is why it says that g of x cannot equal x, because then we wouldn't have this du over dx. Okay? Another way to think about it is we could take this inside function with respect to x, okay, times the derivative of g prime of x. Okay, so all in all, we could really just sum it up by looking at this equation right here. But if that confused you, let's look at an example that might help out. Okay, so here we want to find the derivative. Okay, so we're really looking for d over dt of the definite integral from pi over 2 to x cubed of cosine t dt. Okay. Now, one way we can do this, let's just do this one way over here. And I'm going to show you the U substitution method here. And so we're just going to let u equal that x cubed. Okay, so let u equal the x cubed. And so what that means is our g of x actually equals our x cubed. And we need to find g prime of x. Okay, so going back, we actually need to remember differentiation. So remember, this is going to be 3x squared. So if 3 comes in front, decrease the power by 1, so 3x squared. Now we basically have everything to be able to solve this problem by using this formula here. So it's our function, which is just cosine. So another way we can write this is f prime of x, capital F prime of x, equals our function of g of x, and in this case it's x cubed, times the derivative of g of x, which is 3x squared. Okay, so this method is using U substitution. Identify your u, let that equal g of x, find g prime of x, and then go ahead and plug it into this function right here. Now, a little bit quicker way, I think, to think about this is if you have the derivative of an integral where this is a function, is simply to plug this function in for t. Okay, because we know the derivative gets rid of the integral, but we do have to plug the x cubed in. So we're going to plug in the x cubed here for t, and then we're going to plug in the x cubed here for t as well. So what this gives me then is the cosine of x cubed times the derivative and we're just going to say with respect to x of x cubed. Okay, so I think this method right here, we'll call this our second method for reference, is to just plug in the x cubed into the t and the t here, and so it becomes cosine of x cubed times the derivative of x cubed. And then at this point, you just take the derivative of x cubed, and so we're left with cosine x cubed times, well, derivative of x cubed is 3x squared. And you can see that either method we use, we end up with the same answer. Because they're essentially doing the same thing, I think this process is just a little more streamlined. All right, I want to show you one more. We'll do letter B together, and then I'll let you try example 2. So again, we're trying to find this derivative. Okay, so I'm going to rewrite this d over dx of the integral from 2 to x squared of 1 over t squared dt. Okay, and I'm going to use a U substitution, but I'm just going to do it very quickly by substituting this in for t in both of these places. So this is going to be 1 over, substitute in x squared, and then times the derivative of x squared. And so I get 1 over x to the 4th times 2x. And so we had 2x over x to the 4th, which is 2 over x cubed. And there's our final answer. So now you know how to deal with this when you have a function as your limit of integration. Go ahead and try example 2 on your own. Go ahead and pause the video and then come on back when you're done to check your work. Alright, welcome back. So you should have substituted this x squared in for t here and here. Okay, again, because the derivative of an integral cancel each other out. And then just simplifying this, x squared squared becomes x to the 4th. The derivative of x squared is 2x. And then I just moved it around in front just so it looks a little bit nicer. Alright, so that's how we can use the chain rule with the second fundamental theorem of calculus.